So we're going to do one more example of solving these. It always boils down to the same thing. We got to factor it and then find all the solutions to each of the factors. Notice that this one doesn't equal 0. So that's job number 1, just like when we were solving quadratics. So I'm going to add 16x to both sides. 9x to the 5th minus 24x cubed plus 16x is 0. That's step 1. And then I look and I'm always going to go for the easy things first. I notice that I have x's in every single term, so I'm going to factor out an x, kind of like I did with the previous example. 9x to the 4th minus 24 x squared plus 16, that equals 0. And then I look at this thing and I got to factor this. I could use a quadratic equation if I wanted to. I'd have to be a little sneaky about it. But what I do notice is that this is a perfect square. This is a perfect square. And then this perfect square is 3x squared. This perfect square is 4, or the square root of these things, 3x squared and 4. If we multiply them together, we get 12x squared, and if we double it, we get 24x squared. So this is actually a perfect square. So I now know that this can be written like this. 3x squared plus, minus 4 squared. So I happen to know that that's the case. And then I look at this thing here and I go, ooh, that, not quite a difference of 2 squares, but certainly very, very solvable. So instead of writing it like this with the square, I'm going to write it a little easier for myself to see it. 3x squared minus 4. And I need to now factor one of these, but when I factor one, I'll have the factors of the other one because they're the same. So I need to factor this, and I could look at this as a difference of 2 squares. I could solve it directly. There's so many ways to solve this. I am going to just look at it as a difference of 2 squares because that's where my brain is. So I'm going to say that the factors of this is root 3x plus 4, root 3x minus 4. I've got to remember this original one. And I know that there's 2 of them, so that means there's going to be 2 of each of those. I could list them all out again, right? I did this one turn into both of these. I could do this again, but it's just 2 of the same thing. And so now I got to figure out all my zeros. This one here is easy. I'm going to just draw some arrows. X equals 0, right? When that's 0, that's that. This one here is a little trickier. Root 3x plus 4 equals 0. I subtract 4 from each side. I say root 3x equals negative 4. I divide both by the square root of 3. X is negative 4 over root 3. I should rationalize the denominator, meaning I got to multiply by root 3 over root 3. So I'm going to get negative 4 root 3 over 3. So that right there is a duplicitous root because there's 2 of them. So I'm gonna make another note to myself. I don't know. I guess it's right there, right? And maybe I'll write duplicitous because there's two of my roots are those. That's a real root, by the way. It's not a complex root. So then I need to do the same thing here. I think that you can see this is the same as this, except for this is a negative sign, so that means this is going to be a positive, and then everything's going to work out the same. So I'll also have the root x equals 4 root 3 over 3, and this also is duplicitous, right? And that means I get to count it as 2 of them. So this is 2 of my roots, this is 2 of my roots, this is 1 of my roots. That's 5 real roots. None of them are complex. And I was expecting 5. So this worked out perfectly.